So welcome back to the video OSPF part 3. In this video we are going to see more detailed version of OSPF, how it works, what state it goes. So let's go. So first of all, the routers needs to be OSPF neighbor. So making sure that the router successfully become OSPF neighbor is the main task in OSPF and for like troubleshooting OSPF. So once the router become neighbors, they automatically do the work of sharing network information, calculating routes and many other things. So when OSPF is activated on interface, the router starts sending OSPF hello messages out of the interfaces at regular intervals, that is at hello timer, and then these are used to introduce the router to potential OSPF neighbors. So the hello timer is like 10 seconds on Ethernet connection, and then hello messages are sent to a multicast address, that is 224.0.0.5. So this is like a multicast address used for like all OSPF routers. So first of all thing, two routers needs to be neighbors, and then they sent a hello message at regular hello messages in a 10-second interval at 224.0.0.5 multicast address. So the first state is like the down state. OSPF is activated on the R1's G00 interface over here, and then it sends hello message to the multicast address 2224.0.0.5, and then the hello message contains the router ID 1.1.1 and the neighbor ID is 0.0.0. So it doesn't know about the OSPF neighbor yet. So the current neighbor state is down. So since it doesn't know anything about the neighbor, so that's why the first state is down state. Second, it is like a init state. When R2 receives the hello packet, that is from R1 to R2, R2 receives the hello packet, it will add an entry for R1 to its OSPF neighboring table. So in R2's neighboring table, the relationship with R1 is now in a init state. So that's why the state is called init state. So init state is like hello packet has been received, but own router ID is not in the hello packet. So it has just received the R1's router ID, but it hasn't showed its router ID to R1 yet. So like basically receiving the hello packet is like the init state. Then we have two-way states. So R1 will send a hello packet containing the router ID for both the routers. So since once it reaches the R2 knows the router ID of R1, so it will just send a hello packet destined to R1. So it will just tell like my router ID is 2.2.2 and the neighboring ID like from the source ID like 1.1.1. So R1 will insert R2 into OSPF neighbor. So since once the packet reaches in R1, it will insert into R1 table in the two-way state. So R1 will send another hello message, this time containing the R2's router ID. Now both the routers will are in the two-way state. So once the R1 receives R2's hello message, it will just update neighboring table and then send again a hello packet destined to R2's router ID. So this is like a two-way state sending each other the hello packet. Now the two-way state means the router has received a hello packet with its own router ID in it. So if the router reaches the two-way state, it means that the condition have been met like of OSPF neighbor. So they are now ready to share LSAs. So once they become neighbor, they can share the LSAs, and then in some OSPF network types, a designated router DR and a BDR, that is backup designated router, will be elected at this point. So you don't need to worry about this thing. So like, and then fourth step is like the ExStart state. So here the two routers will now prepare to exchange the information about their LSDB. So it will just exchange the LSAs. Before that, they have to choose one router, which one router will start exchange. So they start doing this in a ExStart state. So basically the router will with the highest router ID will become the master. In this case, the router ID of R2 is 2.2.2, which is greater than router 1's router ID 1.1.1. It will so one with the greater will become master, and the lower ID router ID will become the slave. So to decide the master and slave, they exchange the DBD, that is called database description packets. So once they like R1 sends like I will be the master, but R2 says like I have higher router ID, then it will say no, I will be the master over here. So let's go further over here, and then fifth state is like the exchange state over here. So in the exchange state, the router exchange the database description which contains a list of LSAs in their LSDB. So this database description do not include detailed information about the link state advertisement. It just has the basic information. The router compares the information in their database description they receive or to the information in their own LSDB to determine which link state advertisement they must receive from the neighbor. So they just share the LSAs in the form of DBDs, and then there is a loading state in this where the router send link state request message to the message to request their neighbor to send them LSAs they don't have. So suppose there is a big network, it will just request like can you send me the LSAs which I don't have. So it will just take place in like and then once it requests, it will just send an update over here like in LSU link state update, and then the router sends LSAC. So that is like a link state acknowledgement to that saying that I have received the LSAs which you have been sharing me. So and then there is a full state. So in this full state, the router has full OSPF adjacency and identical LSDP on the both side of the router. So they have typically the whole network map, connectivity map on both the routers. So they continue to share hello packets every 10 seconds to maintain a neighbor adjacency. Every time a hello packet is received, the dead timer which is like 40 seconds by default is reset. So once let's say R1 sends a hello packet on this, and then here 40 seconds starts. So if the dead timer count to 0 and no hello message has been received like in like for those 40 seconds, the neighbor will be removed. The router will continue to share LSAs as the network changes to make sure that each router has complete and accurate map of the network. So the hello and the dead timer is just to make sure like if they have like complete map of the network. And then like let's summarize the 7 steps over here. First state, down state, like router 1 will just send his router ID to R2. Init state, like R2 has received the router 1's RID. Router 2 like two-way state, like router 2 will send R1 that its router ID, and then it will just send another message to R2 updating the router 2 ID in it, and then over here the like the designated router or backup designated router election takes place. Fourth, we have ExStart state in which it decides who will become the master and slave depending on the router ID, and then in exchange state it just shares the database description packets, and then which describe the content of LSDP like the LSAs. And then the loading state, it will just request whatever LSAs it's missing, it will update the routing table like OSPF neighboring table, and then acknowledge that I have got everything, and then it will just synchronize both the LSDB on the both routers, and then we have full state in which it is ready to rock and roll in the OSPF network. So that's how the 7 steps are. So remember in the previous part 1 I told like there are 3 main steps, that is first they become neighbors, then they start exchanging LSAs, and then they calculate the best path to the destination. So in this 3 you can see down init two-way state, like they become neighbors first by sharing their RIDs, and then once they decide like who is the master and slave, they start sharing the LSAs and then update the LSDB, and then start sharing the network on their interfaces on the both the routers. So this is how OSPF works in general. So that's all for this video. Stay tuned for the one more part of OSPF in which I show you a configuration in Cisco Packet Tracer, and you will get a clear idea by hands-on experience. Thank you.